Alright, so I'm going to try to basically give some background on this video and then also do number two in the process. So what we're trying to do is take these points and write an equation that models those points. Um, on my calculator, I have done a, um, let's see, I've made a list that has those points in it. And so you can see that I have x and y pairs. And so when you graph those, they look like this. What does that look like? Looks like a line, right? Whoops. Okay, no, that was good. Looks like a line, right? Y equals mx plus b. Sound familiar? Okay, b is the y-intercept, 0, 2. And then the slope, how much does it go up and over? It goes up half as it goes over 1. Then it goes up another half, and then it goes over 1. And so just by looking at those points on a graph, hopefully you can see that this is a linear equation. But how can we know that just by looking at the, the table of values? Well, these are x values here, and these are y values. And so we want to find the differences here. Okay, so you start on the far right, or with the biggest x value, 4.5 minus 4.5. 4 minus 3.5, 0.5. And you'll notice all of these are 0.5. Why are they all 0.5? Because they have a common first difference. There is a consistent difference between the y values as we change by the same x amount. Change in y over change in x. That is the slope for a function, for a linear function. So for example, if we did 3 minus 2.5, that happens 3 minus 2.5 over, what's the change in x? 1. And so this slope is 0.5. All right, well, when we talk polynomials, we talk more about a, b, c, d, e, and even f sometimes, depending on what the function calls for. And so this is a linear polynomial because it has a common first difference, which is written in the form ax plus b. So if it is a linear function, then the common difference is equal to the value of a, this number right here. So for this one, y equals 0.5x, and then we still need to know what b is. Okay? And I've been saying it a long time that b, whenever x is 0, the value of y is going to be b. So it's plus 2. But let's take a quick pause, and this applies for all of them, every polynomial. The reason that b is the y-intercept plus b is there's a point, right? So this equation should give me every single one of these data points. Every single one of these xy pairs, I should be able to plug into the equation and it should be true. So if I plug in a 2 for y and a 0 for x, the value of b has to make this thing be true. Well, what's 0 times 0.5? 0. So on the right side is only b, and on the left is 2. So I know that the y-intercept is 2, and that happens to also be the constant term. Right? Now for different functions, the constant term isn't always b. Now let me show you what I mean by that. If it's linear, so we always start labeling the coefficients with a. If it's quadratic, it would be ax squared plus bx plus c. If it's cubic, ax cubed plus bx squared plus cx plus d, so on and so forth. Okay, so it may not be b, but the common difference here is always going to tell you the value of a in some way. So common, whatever the common difference is, if it is the first one that they share, that tells you a. Second common difference, I'll put CD, is equal to 2a for squared, or for x squared. So if they have a common second difference, not this first one, but if we had to do it again, then whatever that number is would be equal to 2a. If we had to do it again and they had a third common difference, it would be equal to 6a. Okay, so a, 2a, 6a. How are we getting there? A times 2, because it's second degree, is 2a. 2a times 3 is 6a. 6a times 4. So if they have a fourth common difference in common, or the fourth difference is what they share in common, then it's 24a will give you that first coefficient. And then what else do we need to know? The constant term is always the term that's by itself at the end, and it will give you, it will be given to you by the y-intercept. And there's an example later that we'll look at where, what if your table doesn't go there? We can still manage that as well. All right, so we'll call that one quits. Here's the answer to number 2, and we'll pick back up with another one.